This is our first set of notes from Chapter 3. It is Lesson 3.1 on algebraic expressions. So the chapter starts with some new vocabulary. There's a lot of vocabulary in this chapter. Our first new word is, what is an algebraic expression? And lots of people are worried that they won't be able to do algebra. All algebra means is that your expression has some numbers and operations like add, subtract, multiply, and divide, and one or more symbols. All right. The parts of an algebraic expression are the variables. So the symbol that represents one or more numbers is called a variable. All right. And there in this expression, the variable is p, but it could be any letter. We usually use them in the expression, it's usually lowercase, although sometimes when we're writing a formula, like the formula for area equals length times width, then you would use a capital A for area. So sometimes they're capital letters, but usually they're lowercase, all right? And when you see that letter in there, that letter can stand for any number. Now, sometimes kids they make a little pattern and they say, well, A must stand for 1, and B must stand for 2, and C must stand for 3. And that makes perfect sense, but that's just not how we do it. Any letter can stand for any number, right? And that letter is called a variable. And I'm going to write the word letter out beside that. Okay. Variable is a letter. Okay. And then there will be a number. Sometimes there's a number in front of the variable. The numericals, you see the word number in there, factor of a term that contains a variable is called the coefficient. That is certainly a new word. So it's the number in front of a variable. And I'll write letter just so we can remember what a variable is. So the coefficient is the number that is in front of a variable. A term that does not have a variable in it is called a constant. Right? We'll get into that a little bit more, but basically this is called a variable because it can vary, right? In one problem, p might be equal to 6, and in another problem, p might be equal to 7, and in another problem, p might be equal to 8. This number varies, but 4 is constant. It is always worth 4. So when a number is there by itself, that's a constant. But the constant is by itself. Okay, and then I think we need to go a little bit deeper into terms. This expression has two terms. It has this term and it has this term. Terms are separated by either addition or subtraction. All right, so even if you had a lot of like numbers here, or if you had an exponent attached, as long as it was just multiplied or divided, it would still be part of the same term. But as soon as you put an addition sign or subtraction symbol, then you've got a new term, all right? There is a lot of stuff in there, and we will kind of keep using that language so that it becomes more familiar. You'll also review that language again next year, and then you'll be using it a lot when you get to 8th grade and then to algebra. All right, so you have a long time to learn these words. All right, so let's start by just identifying those parts in an expression, all right? An expression, we should probably dig into that a little bit too. An expression is a number sentence that does not have an equal sign. All right. When we get into the next chapter, Then we will start talking about equations, and equations do have equal signs in them, and that's when we start doing a little bit of algebra, as we figure out what the variable stands for because we know what the equation equals, all right? Right now you don't have any equal signs, you just have expressions. So we're going to break that down a little bit. The terms here, there's a plus in the middle, so 5x is one term, and 13 is another term. You know another good way? Oh, look, it says it up here. A term is a part, all right? They are the parts of expressions that are separated by plus and minus. So this expression has two parts. It has 5x and it has 13. Should we go across or down? Let's go across. Let's find the terms here. The terms here are 2z squared. So even though it had a 2 and it was also squared, that was all part together. Y is another term. And then there's a plus sign, so I know that the 3 is another term. All right, this has two terms. If you're looking for a fancy word for that, that's called a binomial. Bi means two. It has two terms. And this one is a 1, 2, 3 trinomial. You don't have to know that in 6th grade. All right, coefficients. Let's see, the coefficient, that's the number in front of a letter. So I see a letter here, and it has a number in front of it, so the coefficient must be 5. 13 doesn't have a letter after it, so it is not a coefficient. Constant, that's a term that doesn't have a variable. It's a number all by itself. Just write that. It's a number by itself. Right? So the constant here is 13. It's by itself. It doesn't have a letter. Right? In this expression, the coefficients, let's see, 2 is a coefficient because it's in front of z. All right, here's a tricky one. Are you ready? In class, I would say, how many y's are there? There is only one y. If there is one of something, it's invisible. I'm going to write that. Let's see, I'm going to say it's invisible 1. You don't have to write out the word invisible for it, but it is important that you recognize that when a variable is sitting there, there is one of them. And so it has a 1 in front of it. We just don't write it, right? And then the constant is 3, because that number 3 is just by itself. It doesn't have a variable at all. I know that those are a lot of new words. There was a lot going on there. We will talk about those words a lot. Okay, you have plenty of time to learn those. Right? Here's a chance to practice with the U-tries. Okay, now we get to actually use the variables. So we're going to remember back to chapter 1 when we used exponents at the very beginning of the year, and we can write a times a times a times a using an exponent where the base is a, and then I have 1, 2, 3, 4 of them, so it's a to the 4th power, right? For B, I have 1, 2, 3 h's, but I also have 1.5 out front. I'm going to keep that coefficient in front of the variable, and then I'm going to put h, and then 1, 2, 3. Right? When I get ready to multiply that, it's only the h that is to the 3rd power. I'm not multiplying the 1.5 to the 3rd power. I'm just multiplying the h's. For now, you don't have to do any math to it. You just have to write it. Right? You have a couple of U-tries here. Okay. And next we are evaluating. Evaluate means to find the answer. So in order to evaluate something, they have to tell you what the variable is worth. If they don't include this part, there's no way for you to know what k plus 10 means if you don't know how much k is. All right, this part has to be here. To evaluate an algebraic expression, you substitute a number for each variable. That's an important word too. We will use this over and over and over, that we're going to substitute a number for each variable, and then you use correct order of operations to find the value of the numerical expression. All right, so we're going to evaluate k plus 10 when k is equal to 25. So I'm going to substitute 25 in for k. I write it there, and I'm going to put the 25 plus 10 underneath. That's showing your work. We're not just going to write an answer. And then your answer goes underneath. Do you remember back when we were using order of operations and I would make you write it down so it looked like a little triangle with the answer at the bottom? Now that we're moving towards solving algebraic equations, and that's really important that it looks like that. No equal signs over here, no stringing stuff across the page. You have to work down. I'm going to actually rewrite this one just because to get away from that word. So I've got 4 times n, and n is equal to 12. So I'm going to substitute 12 in for n, and then 4 times 12 is 48. Hopefully, you looked at the update and you realize that you are now allowed to use a calculator now that we are into chapter 3. So you can still use your multiplication chart, or maybe you know your multiplication facts in your head, but when the numbers get big, you are now allowed to use a calculator. From now, the whole rest of the year. Right, you have 2 U-tries. For this first one, C is equal to 9, and then D is equal to 30. All right, in example 4, now we have 2 variables, but you do it exactly the same way, okay? So give us a chance to practice our division rules. So we've got A divided by B. A is equal to 16. 16 divided by B is equal to 2/3. So first you substitute in for the variable. Oh, how do I do division of fractions? I know. I keep the first number, I change it to multiplication, and I flip the second number. I multiply by the reciprocal. This is a really important idea when we solve equations. You have to be able to multiply by the reciprocal. And we're going to put it over 1. So we've got 2 fractions. And I'm going to go ahead and do a little cross canceling. 2 goes into 2 one time. 2 times 8 is 16. So now I have 8 times 3 is 24. And 1 times 1 is 1. So that's a whole number. All right. And I think there are 4 U-tries with this one. And you don't have any fractions to do on the U-tries. Okay, you're going to divide, add, subtract, and multiply, all with the same numbers. Okay, now we have 1 variable, but we have 2 operations. So now we have a chance to practice our order of operations. And I'm sure we need to review that. And in class, I would say, what do you do first? Well, if we have a grouping, we do our grouping first. So if you have any parentheses, you do that first. And then we do the exponents. And yes, indeed, we do have exponents in these problems. And then we do the multiply or divide. And please remember that we do those from left to right, whichever comes first in the problem. And then we do the add and subtract, also left to right. Okay? Order of operations, it will be with you forever, so learn it. I'm going to first just rewrite 3x minus 14. And then I have to substitute in the 5. This means 3x means 3 times 5, not 35. And I'm going to use parentheses there. We have several different ways that we can show it. We are not going to use an x to show times anymore. And that should be the obvious reason why, because when you use an x, we don't know whether it's a variable or a multiplication symbol. Okay, so no more x's. But you may use parentheses or you may use a dot. Sometimes dots are confusing too because they look like decimals. So I usually use parentheses, but you may use either, but no x's. All right, minus 14. All right, let's see. Which do I do first? Is there any grouping? Well, there is some parentheses, but there's no operations in there. That was just to separate the 3 from the 5. So there's no grouping. Is there an exponent? Nope. Is there a multiply or divide? Why, yes, there is. There's a multiply. So I'm going to do that next. 3 times 5 is 15. And then I would do the addition or subtraction. 15 minus 14 is 1. Notice that everything's coming down. I'm putting the answer each time underneath. This is called simplifying. I start out with a complicated expression, and then it simplifies down to the answer at the end. That's why I like algebra. It's so orderly. And then at the end, it's like, ta-da, there's the answer. Z squared plus 8.5. We're going to substitute in 2 for z. So now I have 2 squared plus 8.5. You guys never make mistakes with this because that exponent is attached right there. Everybody always knows that they're supposed to do exponents before they add. So this is the base of 2. We're going to multiply it by itself. 2 times 2 is 4. And 4 plus 8.5 is 12.5. All right, simplifying down. All right, you have 4 you tries. They're all pretty straightforward, except this one you have to do 2 operations. There's a division and a subtraction. So you have to think about, which do I do first? Do I divide first or do I subtract first? Okay, the last set here, the real life application. On your set of notes, I added the skateboard here. The skateboard, I added a picture of it. The skateboard is on sale for $125. It is. It's on sale for $125. So you are saving money to buy that skateboard. That's a pretty nice skateboard. You begin with $45 and you save $3 each week. This could be something like you might have some money already in your bank account or your piggy bank, or maybe you had a birthday and you get a chunk of money. And now you're getting some allowance money, or maybe you do some chores to earn money, and you can save a little each week for that skateboard. Here's an expression, 45 plus 3W. That gives you the amount of money you save after W weeks. Okay, let's write that expression, 45 plus 3W, and W equals the number of weeks. This is an important step. We always want to define the variable right there, what the variable stands for. And we can solve this problem by making a little chart. Let's see. I'm going to make my chart today. It's going to say number of weeks. That's W. And our expression is 45 plus 3W. Let's break that down just a little bit. This is the money that you start out with. 45, this. And this is the amount of money that you save each week. So you're going to save $3 times the number of weeks plus the 45 that you already had will give you the total that you've saved. All right. And that last column then will be the amount saved. Right? And so it asks you, how much will you have after 4 weeks, 10 weeks, and 20 weeks? So let's write those numbers into our chart. 4 weeks, 10 weeks, and 20 weeks. Right? Substitute. The 4 is going to substitute in for the W. So I've got 45 plus $3 times 4 weeks. So I'm going to save $3 and $3 and $3 and $3. Let's see. If I do 3 times 4, that is 12, and 12 plus 45 is 57. Isn't that nice? You can use your calculator now. In 10 weeks, I would have $45 plus 3 times 10. So the variable is the thing that's changing. The constant stays the same every time. And then the 3 gets multiplied by the variable. Okay, 3 times 10 is 30. 30 plus 45 is 75. Notice I did my order of operations first, multiplied 3 times 10 or 3 times 4. And then after 20 weeks, this is a good one too. So lots of times kids will say, well, if in 10 weeks I've saved $75, then in 20 weeks that must be 75 and 75 is 150. But what that leaves off, let's just check it. 3 times 20 is 60, and then 60 plus 60 plus 45 is 105. In 10 weeks, I saved 75. I did not save 150 in 20 weeks. I saved 105. Why is that? Oh, because this amount was double. Here I saved 30, and here I saved 60. That part doubled, but the 45 didn't double. The 45 stays constant through the whole thing. All right? Be careful about that. That's a really common mistake that kids make. So then B asks you, after 20 weeks, can you buy the skateboard? No. You cannot yet. You are $20 short. So then, in the you try, they say, well, what if you had $45 to start with, but you saved more? What if you saved $4 each week? Then would you have enough after 20 weeks? So you're going to do the same thing. Make a chart, substitute in, and see whether 20 weeks will give you enough to, actually you don't have to make the whole chart. You only have to do for 20. Okay, so substitute in and see if 20 weeks gives you enough to buy the skateboard. Right, after you finish all of your you tries, you can go back and check your answers. Let me push that up so you can see everything. Maybe I'll move it slowly. All right. You can also pause. There's 16. And then if you miss one, you should go back and see how you missed it and check and make sure that you understand.